Okay, so now we've detected that seasonal behavior. You can actually go even further. You can use a specialist statistics package to decompose the line, the time series, the line, into the trend, the seasonal variation, and residual noise. Now, I'm sort of hesitant to introduce this because I'm not quite sure how accurate this is. It does a pretty good job, but let me show you it anyway. So I'm going to take the selected time series, the ones where I know that they've got quarterly seasonality, and then I'm going to do a seasonal decomposition of that of those three line time series, and that's what you get. So the plot is helps you understand what's going on. So you'll see what it's showing you is it breaks that line into 4 plots. So the first plot, the one at the top here, is the original observed data. This is what we would get if we plotted it, in this scale. Obviously, when we saw it earlier, it was much closer together, but that was because it was on a much shorter scale. It's showing the trend of that time series, which is kind of downwards. So that's like if we drew a straight line, if we do a linear regression through it. It's showing us the seasonal behavior, which, as you can see, there's peaks these are at 90 days, so quite regular. And then it's showing us any noise that it hasn't been able to remove. So this gives us its estimate of the seasonal behavior, and then any noise that is still in there, which is quite a small. If you think about the relative size of this, the seasonal behavior goes up to about 0.1, 0.5, and the noise is much less than 1.5. So this is telling us it's detecting good seasonality. Okay, there's the trend, the quarterly seasonality, and the noise. The trend is upwards, quarterly seasonality, and more noise in this case. So look at the scale of the residual. That tells you how much noise there is in the data. There's the trend, the quarterly seasonality, and more noise. And then if we want to look at the weekly seasonality, we can look at those other selected products, H, M, and O. And now we just set the frequency to 7 rather than on the previous slide the frequency was 91, which is, we've detected this frequency. We now put that into the seasonal decomposition and let it do the decomposition at that frequency. So I've changed that to 7 for the ones where we know it's weekly. And then for H, you get something like this, trends upwards, very regular weekly seasonality, and there's some noise, okay, and so on. You can run those examples yourself. So that I think this has limited value, but it can be useful to look at how this package thinks the line should be decomposed into different parts of it. So what's the overall underlying trend? What's the seasonal behavior, and how much noise is there around that? Okay, I'm going to finish there, and then we'll have the last few slides on outliers at the end of the lecture.